All right, now that you've finished the bell ringer, we're going to go into the notes. So we're going to look at naming ionic bonds. Yesterday, Tuesday, you watched 2 videos about naming, and so today we're going to go through some notes. You will be given the polyatomic ion table to keep in your notebook. You'll be given a paper copy of Naming Ionic Bonds to fill in for the notes, and you'll be given a paper for your practice. Like I said yesterday in one of my classes, you may not get finished with the naming ionic bonds part. We may have to finish that up tomorrow. But let's look at the notes. So I'm going to talk you through the notes in this part. Again, if you want to type them, you can, but there is paper copies available. Again, if you're doing it on paper, you can go ahead and submit down here, and then I will check the papers when I return. I always put vocabulary up here, but we just kind of skip over it. So let's do a little bit of review here about compounds. Remember that compounds, some elements will naturally exist in compounds. This just means that 2 or more of them will be chemically combined together. They want to be more stable. They want to have a full outer energy level of electrons. This means 8 electrons for every element. There's 2 exceptions, hydrogen and helium. Hydrogen can hold up to 2, and helium does have 2, and they only have 1 energy level, so 2 electrons makes them full, where all the other elements needs 8. There are 2 main types of bonds, ionic and covalent. Ionic, remember, is between a metal and a nonmetal. The metal is going to be the one losing electrons and transferring them to the nonmetal, and the nonmetal is the one that's going to gain. And covalent is always going to be between nonmetals or nonmetals and metalloids. Electrons are shared. So we're going to talk about ionic compounds mainly. Remember, charged ions, cation is positively charged. They're going to be the metal ion. They're going to lose electrons. The anion is negatively charged, nonmetal ion. They're negative because they're going to gain electrons. So although an ionic compound is made up of charged ions, they have to have an overall charge of 0. So the negatives and the positive charges have to equal so that they have a charge of 0. So positives and negatives, remember, in the same amount, pretty much cancel each other out. All right, so how do we determine a chemical formula from an ionic compound? So in other words, we're given a name and we want the formula. Step 1 is you're going to write down the ions for each element with the charge. So that's why I wanted you to write the charges on your periodic table the other day. So you're going to write their symbol with the charge down. That's the oxidation number. You're going to determine the number of each ion it takes to make a compound with no charge. We're going to use something called crisscross. It's going to make it really easy. You can always draw them like we did yesterday with electron dot diagrams, but this is going to make it simpler. You're going to write down the formula using subscripts to show how many of each ion it took. And then you may have to reduce, just like you reduce in math, you may have to reduce here. So you just have to keep that in mind. So if we have a formula for magnesium, or we want the formula for magnesium and phosphorus. All right, magnesium, remember, is in group 2. So its symbol is Mg. It's going to have a +2 charge. It wants to give away its 2 electrons in the outer energy level. Phosphorus is in group 3, and I think I may have messed up on our bell ringer, so I may have to go back and record that video. Phosphorus is in group 3. So what you do, you have the charge here. you are going to cross that 2 from the +2 is going to be the subscript beside the P, and the 3 in the charge for phosphorus is going to be the subscript for magnesium. So we crisscross here, and this is how we write it. Don't worry about the plus and negative anymore. All right, and you don't have to worry about doing that little piece at the bottom there. So we have aluminum and chlorine. So I'm going to jump back to the Jamboard, and we've got aluminum and chlorine. So I'm going to come over here, and if I want aluminum and chlorine, I'm going to look up aluminum. Aluminum is Al3, and chlorine is Cl minus, because it's in group 7. So I am going to crisscross for that one. So for ones, we don't write anything. So I have Al, and I would write the 1, but I don't need to write a 1. Cl, but I'm going to write the 3 right after the L. All right, so I'm going to go back to my notes, and I'm going to leave it on the small screen for right now. All right, so that's aluminum chloride. So let's see what happens here. So AlC3. Lithium and nitrogen. So I'm going to go back here. Lithium is Li with a plus. Nitrogen is, it has 5, so it has a charge of 3. So I'm going to crisscross like I did here. And this time the lithium has the 1, so, or is going to send the 1 here. Lithium is going to have the 3. I'm going to follow that arrow, and that's where I'm going to put the 3. I'm going to follow this arrow, and that would be where I would write the 1, but remember, we don't have to write a 1. So that is that compound there. Let's look at the next one, magnesium and iodine. So I'm going to go to my Jamboard. I'm going to just clear my frame here. All right, so magnesium, second column, so it has a 2 plus. Iodine is my 7th column, so it has a minus. So I am going to crisscross. So that number is going to go here. That number is going to go there. So when I rewrite it, Mg, I don't write anything because it's a 1, I2. That 2 goes where the arrow points. So that is number 3. Calcium and oxygen. So let's go here. Calcium is Ca2 plus. Oxygen is O2 minus. It has 6 valence electrons, and it needs 2 more. Now, anytime my charges are the same here, not the charges, the number is the same, I'm going to need to reduce. So you can do this one of 2 ways. So when you go this way, you could say that this is Ca2O2, but that will reduce to CaO. Because if I divide by 2, I get 1. If you see that they are the same number, just different charges, you can immediately write it, go ahead and reduce it and write it there. If I had 2 and 4, if I had 3 and 6, those can be reduced. So keep that in mind and look for things that you might have to reduce. What's the last one? Sodium and sulfur. So I'm going to go back. I'm going to clear this. Sodium is Na plus. Sulfur is with oxygen, so it's a 2 minus. And so when I crisscross here, all right, my 2 is going here, my 1 is going here. I've got Na2S. We don't put a number for 1. All right, so taking the names and writing the formulas is is pretty simple. So that's going to be your first practice on the front side of your practice sheet. We'll deal with this. So let's go back into our notes, and we can go through and check and make sure I did them right since I wasn't using my periodic table. So I believe I had all those right. All right, so then you may be given the formula and you need the name. So you're going to write the name of the first element, which will be the metal. So you're going to find the symbol on the periodic table, write the name of that element. Always start with the first 2 columns, and then you might have to look in group 3A for aluminum. But typically they're probably going to be in the first 2 columns. For this, the basic naming, you're going to write the name of the second element, but look at what this says. You're going to change the ending to IDE. Some of you were asking me, well, what's fluoride? What's chloride? Well, that's fluorine, it's chlorine, but when you write the name, you change the second, the nonmetal, to an ending of IDE. It's just what you do for this. So if I have CAS, I know that Ca is calcium, so I would write calcium down. S is sulfur, but it's going to become sulfide, so it'd be calcium sulfide. So you can get the names off of the periodic table, but just remember the nonmetal, you must add IDE. So you're going to drop the ending and add IDE. All right, so we have some practice here. So for this one, Be is beryllium, N is nitrogen. Nitrogen, it becomes nitride, so beryllium nitride. Na is sodium, O is oxygen, so sodium oxide, oxygen becomes oxide. Potassium is K, phosphorus, it becomes phosphide, potassium phosphide. This is aluminum, Al, N for nitrogen, so aluminum nitride. Remember, nitrogen becomes nitride. And then magnesium and chlorine, it becomes magnesium chloride. If you want to make a list somewhere, maybe on your periodic table, that nitrogen is nitride, oxygen is oxide, it may help you, but that's up to you. But you're going to drop the ending of the nonmetal and add IDE. Typically, we would stop here, and then you would practice. Your first page of your practice, basic naming, is what follows what we did here. I want to go ahead and give all the notes at one time. There's 2 exceptions to this naming policy. One is with polyatomic ions. We got a little, in one of the videos, you had a little hint about what this is. This is a covalently bonded group of atoms. Covalently, that means they're going to be nonmetals, and they're going to carry a charge. And you have a table of those listed. You don't have to memorize their charges. You have a table that you'll refer to for that. So here are some common ones to know. There may be a place to write that on your note sheet, but on the table that you have them. You may want to highlight them on that table. So if you're given the formula, you're going to write the name. Well, again, you're going to write the name of the first element, which is going to be the metal, unless it is one of the polyatomics. There's one polyatomic that has a positive charge, and that is ammonium, ammonium. And that will be an exception to this. So you're going to use a special name if it's a polyatomic ion. You're going to write the second element, the nonmetal with an IDE ending, or, this is the exception, the polyatomic ion, you're going to use the special names. Only one of them, I think, has an IDE ending. It's hydroxide. But most of them have a little bit, their ending's a little bit different. They have a special name, and you'll use that name. So here's some examples. Notice I know that this is going to have a polyatomic because I have more than one nonmetal. All right, I have sodium, which is the metal, and then I have phosphorus and oxygen. So to write that, I'm going to write sodium down. I'm going to look on my table of polyatomic ions. I'm going to find PO4, and I'm going to see that PO4 is phosphate. So I'm going to write sodium phosphate. I'm going to use a special name for the PO4. The second one, magnesium, is a metal. SO4, I'm going to find in my table, I'm going to see that it is sulfate, magnesium sulfate. Now the third one, this is the ammonium. Notice they're all nonmetals. Well, the NH4 is a positive ion. So this is an exception to metal and nonmetal for the rule here. It's a positive ion and a negative ion. So we're going to use a special name, ammonium. And then chlorine, we're going to change to chloride. So formula, given the formula, you write the name. So here's some examples. Again, use your periodic table. For the first one, we know Na is sodium. Use your chart of polyatomics. NO3 is nitrate, so sodium nitrate. Use Ca, that is calcium. SO4 is sulfate. Here we have that NH4, so that's ammonium. It's going to be a polyatomic. And oxygen is oxide. Here we have magnesium. Look on the table, phosphate. We have ammonium again with another polyatomic, NO3. So it's going to be ammonium nitrate. So on the back of the first sheet, you're going to have practice with polyatomic naming. So now we're going to take a name and we're going to write the formula. So again, you're going to write down the ions for each element with the charge. That's the symbol and the oxidation. But if you have more than one nonmetal, you're going to have a polyatomic. Look what it says. Keep the polyatomic in parentheses. Write it inside parentheses with the charge outside the parentheses. I cannot stress that enough. Determine the number of each ion is going to make to no charge. You're going to do the crisscross. Keep subscripts outside of the parentheses. Do not change anything inside the parentheses around the polyatomic ion. Write down the formula. Simplify if needed. All right, so we're going to do an example. So you have calcium phosphate here. We know that calcium is +2. Phosphate is PO4. Notice I put that in parentheses and then put the charge. Very, very important. Crisscross. So when I rewrite it, it's going to be Ca3, and that +2 goes on the outside. I don't change anything with the PO4. It's one unit. And so that's my final answer. All right, so barium sulfate. So let me go over here to my Jamboard. And I'm going to try to remember to do this without barium sulfate. So barium sulfate. And I'm going to, on my other computer, I'm going to go ahead and call up a periodic table and a polyatomic ion here. So I wasn't prepared when I sat down. So let me get this up. So barium is in group 2. So it's Ba2 plus. Sulfate, if I come over here, sulfate is SO4. Put my parentheses 2 minus. What do I notice here? I notice that I have a 2 plus and a 2 minus. Look at that, 2 plus and a 2 minus. If my 2's match, I can just go down and I can write Ba. I don't have to have my parentheses now, SO4. If you leave the parentheses, I'll let that slide, but you don't have to have the parentheses. This is what it should be. So let's go back here. So barium sulfate. All right, aluminum carbonate. So I'm going to go over here and I'm going to clear my frame. Aluminum carbonate. I know aluminum is Al3 plus. Carbonate, I'm going to look on my polyatomic ion and find it. It may take me a minute to find it. CO. Don't tell me I picked one that doesn't have. There it is. CO3. CO3. And it has a 2 minus. All right, 3 and 2 are different. This 2 is going to go here. This 3 is going to go outside that parentheses. So I'm going to have Al2 parentheses CO3 parentheses 3. All right. Calcium nitrate. Clear the frame. Calcium nitrate. Calcium is Ca2 plus. Get that from my periodic table. Nitrate, I'm using my polyatomic chart. And nitrate is parentheses NO3 minus. So I'm going to crisscross. The 2 goes here and the 1 goes here. So CaNO3 inside parentheses with a 2. Notice I don't care about the charges when I rewrite it. I only need the charges for the ions. I don't need the charges when I rewrite the subscripts. Sodium oops, I went ahead and showed it. Sodium acetate. So sodium acetate. All right, so sodium is Na plus. Acetate is on my chart, and it's a very long one. C2H3O2 minus. Notice plus minus. I don't need the parentheses. I just write all of that together, because both had a 1 in their charge. All right, and that's what I had popped up here, potassium phosphate. So then we're going to go to potassium phosphate. Potassium is in column 1, group 1. Phosphate is PO4, 3 minus. So that 3 is going to go here. That 1 is going to go here. I don't need the parentheses. K3PO4. If there's going to be a 1 outside the polyatomic, you can drop the parentheses. All right, so the back of that first sheet is your practice. And so you're going to do that. Now, this last section, I'm going to go over, and you can attempt some of these. This is a little more difficult. we're going to at least get the notes done. You may not get to this point in the practice. So remember I said in the middle, those transition metals on the periodic table can be very tricky. They can form different ions. So sodium is always a +1 because it's in group 1 and it will lose 1 electron. But iron, that's a transition metal, can lose 2 or 3. So it has 2 possible ions. And just looking at your formula, sometimes you can't tell which one it is. So when we write their names out, we usually use Roman numerals to tell you which one of the ions we're referring to. And so if you don't remember your Roman numerals, when we get to that section in the notes, you may want to write them down in one of the side columns on your note paper. So copper 1 means that copper can have an ion of +1. Copper 2 means an ion of +2. So you can have an exception, though, when you go to write. This is the exception 2 for transition metals. So we're going to write the name. So if we're given a formula, you're going to again write the name of the first element. So if it's a transition metal, you have to add a parentheses in Roman numeral to indicate the charge. Write the name of the second element, which is the nonmetal with the IDE ending. Remember, if it's a polyatomic, then you would have to use that special name. So here we have 2 copper chlorides. Well, how do we know if it's copper 1 or copper 2? Well, you're going to have to do something called reverse crisscross. So you're going to reverse your crisscrosses, and you're going to figure that out. So the first one here is copper 2 chloride. We know that chlorine has a -1 charge. And so since copper doesn't have a number here, we know that that goes there. And since chlorine doesn't have a number written beside it, we know that this has to be copper 1. Well, the second one, chlorine has a 2 by it, so we know this must be copper 2 chloride. And I'll go over some examples. So this is how you determine the Roman numerals. You're going to reverse crisscross, or you can use some visuals. You can draw things out, use some math, but you're going to need to double check to make sure. So here we have 10 phosphate. So here's option 1, reverse crisscross. This is the method I prefer. So you're going to, all right, what we don't know what 10 is, but we do know from our polyatomic chart that PO4 has a charge of -3. So if we take that 3 and we see that that 3 went there by the 10, then we know that that 4 that's outside of the PO4's parentheses must go with the 10. So we know that this is 10 for phosphate. I know it's confusing, but we're going to do a few of these and just so that you're aware of what's going on here. So option 2, you could actually draw some pictures. There are 3 10s there, and we have 4 PO4s, and each PO4 has a charge of -3. So we know that 4 times 3 is -12, and so we need a -12 over here. And so what times 3 is going to give us a +12? Well, that would be a +4. So you can do it either way. I personally like the reverse crisscross from the option 1. So here's another. So here we're going to have iron, SO4. So we know that SO4 is a -2. We know that there's no parentheses, there's no 2 by the Fe. So it means that if the Fe had a 2 and there's no parentheses and SO4 had a 2, then this must be iron 2. Because there's a 1 there, so it had been reduced. So this is a little bit harder here. So iron 2 sulfate is how you would write this here. Or again, you could do the math. So again, it's going to be 2. So if we're going to do these, so we have FeCl3. So we're going to write the name. That's the simple part. We just have to figure out which iron it is. So FeCl3. So if I come to my Jamboard, we'll clear this. FeCl3. I'm going to take this and I'm going to crisscross it. I'm going to take this, which is a 1, and I'm going to crisscross it. So this means this was a negative and this was a +3. So this is going to be iron 3 chloride. All right, so I took that 3, and I know that chlorine should be a -1. Since there's nothing here, it shows it's a -1. All right, so we've got chromium oxide. So I'm going to come over here and notice there are no numbers. So chromium oxide, make sure I wrote that right. Yes. So chromium, I can write down, and I know I'm going to have parentheses because it's a transition metal, and I know I'm going to have oxide. But when I know that oxygen should be a -2, because I look on the periodic table, so that means that since there's no number, this must have been a +2, so this is going to be a Roman numeral 2. All right, magnesium oxide, or manganese oxide, Mn2O7. So clear frame, Mn2O7. All right, so let's look at this. I'm going to take this 7 and I'm going to put it up here. I'm going to take this 2 and I'm going to put it up here. I know that manganese is going to be +7, so I'm going to put Roman numeral 5 and 2 I's there. And oxide is a -2, so that's right, so I'm going to say oxide. All right, we've got chromium nitride again. Oops, I've already shown it, but let's go through it again. Chromium nitride. Let me see what numbers was with it. None. All right. So I know that nitrogen is a -3. So since there's no numbers, this has to be a +3. So this is going to be chromium 3 nitride. And then silver sulfide. So we have silver, was it 2s? All right, so again, I'm going to reverse crisscross, and I know that sulfur is a -2, and so that means there's nothing here, so this is going to be a plus. So I have silver 1 oxide. All right, so those are a little bit harder. Now, writing the formula from the name is really easy. This is probably one of the easiest ones. You're going to write down the ions for each element using the charge. But what makes it good with this one is that the Roman numeral tells us the charge for the metal. We get the charge for the nonmetal off our periodic table. And then we do our normal crisscross and reduce. We get this, and notice there's 2 2's. We reduce it if needed, and we get FeO. So it's fairly simple with that. So we have some here. So copper is going to be, so we got copper 2 sulfide. So if I come over here, copper 2 sulfide. Make sure it wasn't, sulfide. So I know that copper is Cu. This is a 2, so 2 plus. Sulfide is 2 minus. So I know that this is going to be CuS because the 2's are the same. All right. Iron 1 nitride. So if I come here and I have iron 1 nitride, Fe plus, nitride is 3 minus, that's nitrogen. That goes here, that goes here, Fe3N. Manganese 4 oxide. So I have manganese 4 oxide. That was right? Oxide, yes. All right, notice 4 and 2. I already can tell they're 2 even numbers. I know that I'm going to be able to reduce. So I have manganese 2O4, but I can divide each of those by 2. So 2 into 2 goes 1. So manganese and 4 into 2, 4 divided by 2 is 2. So this would be my final answer. All right, so let's go to chromium 6 sulfide. So chromium 6, chromium is Cr, 6 plus, sulfide is 2 minus. Again, I have 2 even numbers, so when I write this, Cr2, S6, I can divide by 2, so I get Cr, 2 into 2 is 1, S, 2 into 6 is 3. CrS3 is your final for that one. All right, titanium, and I believe titanium is Ti, so let me check and make sure. Find my titanium here in the middle. Yes, Ti. Titanium bromide. So titanium is Ti. Oh, what was that Roman numeral? 4. So 4 plus. Bromide is a minus because it's in group 7. I'm going to crisscross. So TiBr4. All right, so then you're going to have some practice. So here's some summary steps. So pretty much you name the metal, which is the cation. If it's a polyatomic, use a special name. If it's a transition metal, you have to have a Roman numeral in parentheses to indicate the charge. Name the nonmetal with an ID ending, or if it's a polyatomic, use its special name. So that's the notes. So make sure you complete those. You have submitted them. If you did them on the computer, you hand them in to the sub.